Welcome back to the deep dive. Today, we are opening up a topic that, on the surface, sounds like it should be dry, maybe a little technical, full of spreadsheets,
Mm-hmm.
but it turns out to be the absolute difference between a dream job and, well, a living nightmare. We're talking about project management.
It really is the invisible architecture, isn't it? When it works, you barely even notice it.
Right.
But when it breaks, everything falls apart. Everything.
Exactly. And to really set the move here, I want to start with a quote from one of our sources today, Myler Page Jones. He paints this incredibly visceral picture of what bad management actually looks like.
It's a great one.
He says, "I visited dozens of commercial shops, and I've watched in horror as managers futilely struggle through nightmarish projects, squirmed under impossible deadlines, or delivered systems that outraged their users."
Squirmed under impossible deadlines. Oof. That is a feeling I think a lot of us know way too well.
So visceral, right? And that's really the hook for today. We are diving into the foundational concepts of project management, specifically based on Chapter 3 of Pressman's Software Engineering, a practitioner's approach, and the lecture materials that go with it.
And the goal is pretty straightforward.
Yeah.
How do we move from that nightmare scenario Page Jones just described to something that, actually functions?
Just something that works.
Yeah.
And what's so interesting here is that while the context is software engineering, the principles we're going to look at today, what the text calls the management spectrum, they're not really about code.
No, not at all. They're about human nature. They're about organization. And the text breaks this all down into 4 pillars, or as they call it, the 4 Ps.
The 4 Ps. I do love a good mnemonic.
It helps it stick, right? They are the people, the product, the process, and the project.
And crucially, in that specific order.
In that exact order, it matters immensely. As the text points out, a manager who forgets that this kind of work is an intensely human endeavor is, well, they're never going to succeed. It doesn't matter how great their tools are.
So we have to start with people.
You have to start with people.
All right, let's unpack that then. The first P, the people.
Mm-hmm.
This part was fascinating to me because there's this huge disconnect that the source material highlights right away.
Mm-hmm.
They cite a survey of engineering vice presidents, so these are the big decision makers, the people signing the checks, and they ask them a simple question. What is the most important contributor to a successful software project?
And, if you just looked at where the money goes in this industry, you'd expect them to say something like the latest tools or the biggest budget or maybe the fastest servers.
Right, technology. But they didn't. VP number 1 says, quote, "It's not the tools that we use, it's the people."
And VP number 3 is even more blunt about it.
Yeah, he says, "The only rule I have in management is to ensure I have good people." I mean, it seems completely unanimous.
It's a powerful testimonial. But here's the disconnect, and the text is quite critical about this. It notes that while managers say people are primary, their actions often tell a very different story.
How so?
They often treat people as secondary to the technology.
It's the great irony of the industry, isn't it? We say people first, but then we go and buy a new software tool instead of hiring another support person.
Exactly. Or we invest in a new development environment, but we don't invest in training or team building.
It's just easier to use a credit card than to use, emotional intelligence.
That's it, precisely. And that's where this management spectrum really challenges us. If people are your most important asset, you have to understand who they actually are. The text breaks down the players in any given project, and it's not just some monolithic group of coders.
Right, let's look at this cast of characters, because I think categorizing them helps you see where all the friction can come from. First up, you have the senior managers.
These are the people defining the business issues. They care about the big picture ROI, market share, strategic goals. Honestly, they often don't care about the technical details at all.
Just the business outcome.
It's the outcome. Then you have the project or technical managers.
Okay, so these are the people doing the actual planning, the motivating, the controlling.
They're the bridge. They sit between the big business goals and the technical reality on the ground. They are the ones who will be squirming under the deadlines if things start to go wrong.
And then, of course, the practitioners.
The technical talent.
Yeah.
Your engineers, your designers, your testers, the people who are actually building the thing.
But then you have this really crucial distinction that our source material makes between customers and end users. I feel like in bad projects, these two terms just get mashed together.
They do, and it's a disaster when that happens. It's a vital separation. The customer is the person specifying the requirements. They are usually the ones paying for it or, commissioning the work. The end user is the person who actually has to interact with the software once it's out in the wild.
So to put this into a real-world context, the customer might be the CEO of a logistics company who buys a new inventory system.
Exactly. The CEO, who's the customer, wants reports, dashboards, and probably a low cost. That's what they care about.
But the end user,
The end user is the clerk in the warehouse who has to scan boxes for 8 hours a day using that system.
and if the buttons on the screen are too small or the workflow is clunky and slow, the clerk, the end user, is going to absolutely hate it.
Correct. And if you only satisfy the customer, the CEO, but you outrage the end user, the clerk, just like Paige Jones said in the intro, you failed.
The whole project has failed.
The system won't get used properly, the data will be bad, and eventually the entire project just collapses under its own weight.
That makes perfect sense.
Yeah.
So leading this whole cast of characters is the team leader. And the text references this model by a guy named Jerry Weinberg. It's called the MOI model. MOI.
This is a bit like a government agency or something.
It does. But it's actually about leadership traits.
And it's a great framework for understanding what leadership really looks like in a technical field. It stands for motivation, organization, and ideas.
Okay, let's start with M, motivation. That's the ability to encourage people to produce their best work, right?
Yes, but the text is more specific. It's the ability to push or pull technical people. It's not just being a cheerleader.
Push or pull. What's the difference?
Well, sometimes you need to drive the team, push them toward a hard deadline. Other times you need to pull them along, inspire them with a vision, or even protect them from outside pressures. It's about reading the emotional state of the team and applying the right force.
Okay, so M is motivation, O is organization.
And that's the ability to mold processes. And this is key. It's not just about filing paperwork or setting up a digital task board. It's the ability to invent new processes if the old ones aren't getting the job done.
So it's more about structural problem solving.
Exactly. If the team is blocked, the leader organizes a way around that block. They clear the path.
And finally, I, ideas or innovation.
This one is tricky. It's the ability to encourage creativity, but, and the text is very specific about this, within bounds.
Within bounds. I like that. Because otherwise you just get, what, chaos?
You get chaos. Or you get what's sometimes called resume-driven development,
I've seen that.
where engineers decide to rebuild the entire database engine from scratch because it would be fun and look good on a resume, not because the project actually needs it.
Right. You can't reinvent the wheel if the client just ordered a bicycle.
That's a perfect way to put it. A good leader encourages innovation that serves the product, not just innovation for its own sake.
The text also says successful leaders use a problem-solving management style. How is that
Yeah.
different from just management?
It's a contrast with what you might call personnel administration. A personnel administrator just moves resources around on a spreadsheet.
They're a bureaucrat.
Right. A problem-solving manager, on the other hand, concentrates on the technical and human problem that needs to be solved. They're technically aware. They understand why a task is difficult. They're engaged with the substance of the work, not just the process.
So you have a leader, you have the players. Now you need a team. And there's this really interesting concept in the text called gelling. It sounds like you're making jam.
And in a way you are. A gelled team is one where the whole is greater than the sum of its parts. It's that kind of magical state where team members trust each other, skills are distributed correctly, and they're all working as this one cohesive unit.
And when a team gels,
Communication becomes shorthand. People anticipate each other's needs. Productivity just skyrockets.
but the text spends a lot of time warning us about the opposite of that. Team toxicity, the things that actively prevent a team from gelling.
Yes, the 5 toxins. These were identified by Jackman, according to the notes. And honestly, reading this list is like looking at a diagnostic manual for every failed project or startup you ever heard of.
Okay, let's run through them because I think our listeners are going to recognize these instantly. Number 1, a frenzied work atmosphere.
Oh, yes. The everything is on fire all the time mode of working.
Panic instead of planning.
Exactly. Management often thinks that if everyone is running around sweating, then work must be happening. But usually, it just means mistakes are happening faster.
Right. Okay, toxin number 2 is high frustration caused by friction.
And this can be technological friction, bad tools, slow servers, or it can be personal or bureaucratic friction. If I have to fill out 3 forms in triplicate just to get a license key for a piece of software,
That's friction.
that's friction, and it grinds the team's morale down to nothing.
Number 3, fragmented or poorly coordinated procedures.
This is where nobody knows what the standard is. You hear things like, wait, I thought we were doing it this way. And the response is, no, we changed that in the meeting you missed.
It creates chaos.
Total chaos. Work gets duplicated or, worse, overwritten.
Number 4 is an unclear definition of roles.
This one leads directly to the finger-pointing stage of a project's failure.
I thought you were testing that module.
No, I thought you were. When roles aren't clear, accountability just vanishes into thin air.
And the last one, number 5, sounds the most depressing of all. Continuous and repeated exposure to failure.
That is the ultimate morale killer. If a team feels like they are constantly missing deadlines, getting swamped with big reports, requirements changing at the last minute, their confidence just evaporates.
A team that expects to fail will probably fail.
They will absolutely fail.
So if you're a manager and you're seeing these toxins starting to creep in, the frenzy, the friction, the fragmentation, what do? The texts suggest some antitoxins.
Right. And they are surprisingly straightforward, though. They can be hard to implement in practice. One is giving the team real control over its own decision-making.
Autonomy.
Exactly. That reduces frustration because they feel like they have ownership. If the team gets to decide how to solve the problem, they own the solution. They're invested.
Another one listed is, don't keep bad news secret. That one seems a bit counterintuitive. Usually management wants to shield the team from bad news to keep them focused.
But secrecy just breeds mistrust and rumors. If there's a budget cut or a competitor just launched a new product or there's a major delay, tell the team.
Get it out of the open.
Yes. If you deliver bad news early, the team can react to it. It becomes a problem to be solved. If you hide it, it becomes a bomb that goes off later and destroys all trust.
And finally, define roles clearly, which just seems obvious.
It is, but it's so often overlooked. Stop the finger pointing before it even has a chance to start. Everyone needs to know exactly what they're responsible for.
So that covers the first P, the people. It really is the foundation. But you can have the greatest people in the world, a perfectly gelled team, an amazing leader, and still fail miserably if you don't know what you're building.
And that brings us right to the second P, the product.
The product. This is where we define the scope. The text makes a very, very strong statement here. It says you cannot manage a project, you cannot estimate the cost, and you cannot have a reliable schedule if you don't know what you are building.
It sounds so obvious when you say it like that.
It does. But how often does a project start with a vague statement like, we need a new website? And nobody stops to ask, okay, but what does this website actually need to do?
All the time. Or, my favorite, we need an app. Great, an app for what? Oh, everything. That is not a scope, that's a wish list.
So how do you define the scope properly?
The text suggests we need to answer 3 specific questions to nail it down.
Okay, let's break those down. First one is context.
Context asks, how does this piece of software fit into the larger system or business context? Is it a standalone app on a phone, or is it a tiny cog in a massive factory machine?
So you can't build it in a vacuum.
You can't. If you're building a new navigation system for a car, the context includes the car's hardware, all the sensors, the safety regulations. It's not just code.
Okay, that makes sense. Second question is information objectives.
This is all about the data. What data objects go in and what data objects come out. If you can't define the inputs and the outputs, you don't really understand the product.
Are we inputting text from a user? Voice commands? Images from a camera?
And are we outputting a report? A graph? Control signals to a piece of machinery? You have to know.
And the third question is function and performance.
Function is the transformation. What do we actually do to the data once it's inside the system? And performance is the constraint on that function.
How fast does it need to be?
Exactly. Does it need to be lightning fast, handling 1 million users at once? Or is it a back office tool for 3 people where speed isn't the most critical factor?
So once we have those answers, context, objectives, function, performance, we have our scope, but usually the scope is huge. It's build a new word processor. That's still way too big to estimate, isn't it?
It's impossible to estimate build a word processor with any accuracy. If I asked you to estimate that, you'd just be pulling a number out of thin air.
So what do you do?
So the text introduces the core strategy of problem decomposition, or as it's more commonly known, divide and conquer.
You break it down into smaller pieces.
Exactly. The text uses that specific example of a word processing product. You can't estimate the whole thing, but you can start breaking it down into its functions. You have a voice input module.
Okay.
You have a spell check module, a page layout module, a file management module.
And I can wrap my head around spell check.
Yeah.
I can start to picture what that involves. I'd need a dictionary, some kind of lookup algorithm, a user interface for showing the corrections.
Precisely. You partition the huge, complex problem into smaller, much more manageable parts. And suddenly, estimation isn't a wild guess anymore. It's possible.
And you can sum up the estimates for the small parts to get an estimate for the whole thing.
You can. And even more importantly, you identify the risky parts. You might look at your list and say, okay, we know how to do spell check. We've done that before. But this voice input module, we have no idea how to do that.
So decomposition is also a form of risk analysis.
A very effective one.
That's incredibly valuable. So we have the people. We have defined and decomposed the product. Now we need a plan for how to actually build it. Which brings us to the third P, the process.
The process. And the key takeaway from this section is one word: adaptability. The text really emphasizes that a process isn't some rigid law that's handed down from on high. It has to be adapted to the people and to the specific problem you're solving.
So you might choose a different process model depending on the job, like a simple linear model for something that's really well understood, but maybe a prototyping or spiral model for something that's new and risky.
Correct. If the requirements are perfectly clear and not going to change, a linear process is fine. If the customer has no idea what they want, you better be building prototypes.
But once you pick that model, how do you apply it to the product you've just broken down?
This is where the text introduces a really neat concept it calls melding product and process. It asks you to visualize a matrix.
Okay, let's paint a picture of this for the listeners. We're talking about a grid.
Imagine a grid or a spreadsheet. On the left side, going down in rows, you list all those product functions we just decomposed.
So text input, editing, spell check, and so on. That's the what.
Exactly, that's the what. Then, across the top, in columns, you list the activities from your common process framework. These are the things you always have to do no matter what the project is.
Things like communication, planning, risk analysis, engineering, delivery.
Right. And now you have this grid of cells. And the manager's job is to look at the intersection of, say, the spell check row and the risk analysis column and ask a very specific question.
How much effort is required right here in this specific box?
Exactly. Maybe the risk is super low for spell check, but you go down to the voice input row and look at the risk analysis column, and that cell might be huge. It might represent months of work.
I see. It turns a vague, overwhelming project into a series of very specific, concrete boxes you have to think about.
It forces you to think about the entire process for every single feature. And this leads to another level of breakdown, which the text calls process decomposition.
Just like we decompose the product, we have to decompose the process tasks themselves.
Yes. And this is where the text gives a great comparison between a small project and a really complex one.
Right. They use the example of customer communication. That's a framework activity. It happens in every single project.
In every project. But for a small project, let's say you're building a simple tool for a single user. The tasks inside customer communication might just be make a phone call, have an hour-long meeting, and write a one-page scope statement. Total time, maybe 48 hours.
Simple, straightforward.
But for a very complex project like building new flight control software, the activity is still customer communication, but the tasks are completely different.
You'd have to do things like research existing approaches, conduct dozens of facilitated workshops, write mini specs for every feature, hold formal reviews with stakeholders,
create detailed scoping documents. The list goes on. The activity communication is the same, but the tasks differ wildly in scale and complexity.
That's a really helpful distinction. The framework of activities stays the same.
Yeah.
It's the tasks within them that scale up or down.
Exactly. And that flexibility is what saves you. If you tried to apply the complex task set to a small project, you drown in useless paperwork.
And if you tried to apply the simple task set to a complex project,
you'd be flying completely blind. You have to adapt the process.
Okay, so we're 3 Ps in. We have our people, our product, and our process. Now we get to the final one, the one that ties it all together. The 4th P, the project.
The project itself. And this is where, the rubber really meets the road. This section of the text is all about managing that complexity in the real world and avoiding the common traps that kill projects.
And speaking of traps, there is a rule mentioned here that made me laugh, but it's also kind of terrifying. It's called the 90-90 rule.
Ah, yes. A classic bit of engineering humor based on painful truth. It goes like this. The first 90% of a system absorbs 90% of the allotted effort and time.
Yeah, it sounds about right.
The last 10% takes the other 90%.
So the whole project takes 180% of the time.
It's a joke, of course, but it is mathematically accurate to how so many projects feel. You fly through the beginning, the design, the easy coding. It feels great. You tell your boss, I'm 90% done.
But that last 10%.
That last 10%, the integration, the final bug fixing, all the weird edge cases, the documentation, it just drags on forever because the true complexity wasn't managed from the start.
So to avoid that 180% timeline, the text references a writer, John Reel, who lists 10 signs that a project is in jeopardy. These are like the warning lights on your car's dashboard.
They are. We don't have time for all 10, but there are a few real heavy hitters in there.
Which ones stood out to you as the biggest red flags?
Well, the first one is software people don't understand customer needs. That goes right back to our scope conversation. If the builders don't know what the user actually needs, they're building the wrong thing.
You're running a race, but in the completely wrong direction.
Exactly. Another big one is deadlines are unrealistic.
Classic. And that often comes from outside the team, doesn't it?
Almost always. Someone in sales or upper management picks a date because of a trade show or the end of a fiscal quarter, not based on the actual work required. If the team knows the deadline is impossible on day one, the project is already in jeopardy. Morale is shot from the start.
And what about sponsorship is lost?
That one is absolutely deadly. This is about the corporate champion for the project. If the VP who authorized your project leaves the company or just loses interest,
The project becomes a zombie?
it becomes a zombie. It keeps walking, but it's dead. Resources get pulled, key decisions stall. You have to have an active, engaged sponsor.
So John Reel gives us these signs of doom. Does he give us a way out of the doom spiral?
He does. He proposes a 5-part approach to success. It's basically a roadmap for how to avoid these problems in the first place.
All right, let's run through them. What's number one?
Start on the right foot. This means understand the problem hard before you write a single line of code. It goes back to scope. Don't rush into programming. Spend the time up front to really, truly define the objectives.
Measure twice, cut once.
That's the idea. Number 2 is maintain momentum.
And this is about the team.
All about the team. Keep your turnover low. Provide real incentives. The text specifically mentions quality incentives, not just speed. If you lose your key people halfway through, momentum just dies. You spend the next 3 weeks just training their replacements instead of building.
Number 3, track progress.
And this is so crucial. Track it with actual work products.
Yeah.
Don't just walk up to a developer and ask, how's it going? And accept the answer, oh, it's about 50% done.
Because what does 50% done even mean?
It's meaningless. Real says you track things that are tangible. Finished design specs, code modules that have passed their unit tests, things that are actually done.
I'm 50% done is probably the biggest lie in project management. It usually just means I haven't started the hard part yet.
Exactly. It is the 90-90 rule just waiting to happen.
So what's number 4?
Make smart decisions. And his advice here is basically keep it simple.
Don't over-engineer it.
Right. Use off-the-shelf components whenever you can. Don't build a custom user interface if a standard one will work. Complexity is the enemy of project completion. If you can buy it, don't build it.
And finally, number 5.
Conduct a postmortem. When the project is over, whether it succeeded or failed, you have to analyze what happened, learn from the mistakes. If you don't do this, you are absolutely doomed to repeat the same nightmare on the very next project.
You have to institutionalize the learning.
You have to.
So that covers the 4 Ps. We've analyzed the people, the product, the process, and the project. But the text also provides some really practical frameworks, almost like cheat sheets, for our listeners to take away.
It does. One of them comes from Barry Boehm, who is, a giant in this field. It's called the W5HH principle.
W5HH. It sounds like a radio station call sign.
It does, but it's actually an organizing principle for any project plan. It's a series of questions: why, what, when, who, where, how, and how much.
It's just brilliant in its simplicity. Let's break that down quickly because this is something anyone could use, even if you're not building software.
Absolutely. First, why is the system being developed? That's your business validity. If you can't answer why you're doing this, you should probably stop.
Okay.
What will be done? Those are your tasks and your milestones. When will it be done? That's your overall timeline. Who is responsible? Those are your roles and responsibilities.
And the where. That seems like an interesting one.
Where are they located? That's organizational logistics. And in today's remote and distributed world, this question is huge. Are we all in the same time zone? Do we have access to the same systems, the same data?
Right. And then the two H's.
How will the job be done? That's your technical and management strategy? Are we using an agile methodology? Are we building this in C++ or Python? And finally, how much of each resource is needed? That's your estimation, your budget.
Boehm's point is that if you can answer all of those W5HH questions, you basically have the skeleton of a solid project plan.
You do. It's a fantastic sanity check. If you are staring at a blank project plan and you're just feeling completely overwhelmed, just write down W5HH and start answering the questions.
I love that. The final framework mentioned comes from a group called the Airlie Council. They're called Critical Practices, and they offer some quick look questions to see if a project is healthy.
Yeah, these are high-level integrity checks. If I were coming in to audit a project, these are the first things I would ask.
Like what?
First, formal risk management. Do you maintain a top 10 risk list? If I walk into a project manager's office and ask for their top 10 risks, and they just stare at me blankly,
That's a bad sign.
I know they aren't managing the project is managing them, because something will go wrong.
It always does.
Always. And if you haven't even thought about what it might be, you're going to be reactive, not proactive. Second is defect tracking. Are you tracking defects against quality targets? Are you even counting the bugs? If you aren't counting them, you can't manage quality. You're just shipping it and hoping for the best.
And the last one you mentioned ties all the way back to where we started this whole conversation.
It does. People-aware management.
And the specific question is,
Are you tracking staff turnover? If people are fleeing your project, that is a quantifiable, metrics-based red flag that something is toxic in that environment. It connects right back to the 5 toxins we discussed an hour ago.
high turnover means the team hasn't gelled, the atmosphere is frenzied, or the roles are completely unclear.
It's a symptom of a deeper disease in the project.
It really does come full circle, doesn't it? We started with people being the most important thing, and we end with checking to see if the people are quitting.
It has to. Because at the end of the day, software is built by human beings. We try to make it engineering, we try to make it about math, but ultimately it is a deeply social activity.
So let's try to synthesize this whole deep dive. We started with Paige Jones's nightmare of squirming managers and outraged users, and we walked through the management spectrum of the 4 Ps to find a way out.
We saw that people are the primary asset, but they're often the most neglected. We learned we need leaders who can motivate, organize, and innovate. We need teams that can gel and avoid those toxins like frenzy and friction.
Then we saw that the product must be defined. You have to scope it, context, objectives, function, and then you have to decompose it, break it down into manageable pieces.
After that, the process must be adaptable. You use that matrix idea to match the right amount of effort to the right task. You don't use a sledgehammer to crack a nut.
And finally, the project itself has to be actively managed to avoid that dreaded 90-90 doom loop. You have to track real progress, maintain team momentum, and crucially, learn from your mistakes.
That's it in a nutshell.
And the key insight from the text for me, I think, is that while the tools and the technology change constantly, we have better servers, better languages, better everything now than when some of this was written, the fundamental management challenges haven't changed at all.
Not one bit. Dealing with human nature, the sheer difficulty of defining what a customer actually wants, the need to build and maintain momentum, those are timeless constants. They were true in 1990, they are true today, and they will be true in 2050.
It's almost comforting in a strange way. The problems are known and the solutions are known. We just have to have the discipline to actually apply them.
That's the perfect word for it, discipline. Management isn't some kind of magic, it's discipline. It's applying these faux Ps every single day, not just when things are on fire.
I want to leave our listeners with that provocative thought again, but the 90-90 rule. As you go back to your work today, just ask yourself, in whatever project you're on right now, are you in the first 90%?
Are you cruising along thinking it's all going to be easy from here?
Or have you unknowingly, just in the last week or so, entered that dreaded second 90%? That time where the deadline might have passed, but the real complexity is only just now starting to reveal itself.
And if you realize you're in that second 90%, it might be time to stop typing, take a step back, look at your 4 Ps, and figure out which one broke.
And remember, effective management is the only known way to manage that complexity. Thanks for diving in with us.
Thank you.
We'll see you next time on The Deep Dive.